Okay, Assalamualaikum. My name is Muhammad Amshar Shahmi bin Abdul Aziz. So today I would like to present my final year project for 2020, which is FYP1. Okay, so my title is Improving the Design of an Airfoil Fitted with Magnetic Flux as Lift Enhancer. So we continue to the next slide. Okay, before I start, uh, I want to talk about my project or research a little bit. So this research or topic was given to me by my supervisor, who is Sir Azharuddin. Sir Azhar wants me to continue this research because one of his previous final year student, who is named Zain, already done this research. But Sir Azharuddin told me that research has proven that this particular airfoil can produce lift, and the flux will produce lift. So now my responsibility is to improve the flux and to develop more magnetic field and strength of the magnetic field along the wingspan. Okay, introduction. A plane is a vehicle with wings and at least one engine which empower it to take flight in the air. In addition, any area of a wing cut by a plane that is perpendicular to a wing is called an airfoil. Okay, an airfoil are found in propeller, fans, compressor, and turbine. An airfoil-shaped wing will produce downforce. An airfoil shape that passes into a fluid generates a force which is called aerodynamic force. The part of such a force is perpendicular to its motion direction is labeled as the lift. The part that is parallel to its direction of motion is called as a drag. Okay, next. Okay, problem statement. So my problem statement basically that we want to shorten the wingspan. This is because of the small airport with a short runway. So the big aircraft cannot land because insufficient lift before landing and take off. So one of the ways to increase the lift is to do this, which is magnetic flux. Okay, next. Okay, this is my aim and objective. The objective of this project are number one, to design and modify the wing. Number two, to assemble the coil on wingspan. Number three, to evaluate the aerodynamic efficiency. Okay, next, scope and limitation. My scope is this research will focus on improving the design of an airfoil fitted with magnetic flux as lift enhancer. So I want to develop the model that will upgrade the previous student who is Zain, his model. This research also focus on the ability to produce high value of magnetic field by simply the formula magnetic field. Okay, my limitation is that I need to know what is the best material to use to generate the flux. Okay, now I want to move on to my literature review. Okay, what is Bernoulli principle? A Bernoulli principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid potential energy. Okay, the reason why I explained about Bernoulli principle is that my research is related to it. The most common application of Bernoulli principle is in the design of a plane wing. While in flight, the air travels across the top and the bottom concurrently. As you can see, the air on the bottom moves slower, which creates more pressure. It creates less pressure when the air is on top and it moves faster. This effect creates lift and allow the aircraft to fly. Okay, next I want to talk about magnetic field and the magnetic flux. All right, a magnetic field is a field that explains magnetic influence of electrical currents and magnetized material. Magnetic fields are created by magnetized material and by moving electrical charges, and we call it as the electron move. Magnetic field and electrical field have their own relationship to create and accept the hypothesis. Okay, the magnetic flux defined as the total number of magnetic lines or that produced by the magnet. Okay, uh, so magnetic field and magnetic flux, first, they are both interrelated to each other. The magnetic field generates because of the magnetic flux. So, as a conclusion, the magnetic field only depends on the magnet which generates it, whereas the magnetic flux depends on the magnetic strength and the area. Okay, now I want to talk about plasma equator on airfoil shape. When the air flows through an airfoil shape, the air that flows at the top of the airfoil is faster than the air flowing at the bottom of the airfoil shape, will create a differential pressure and creating a vacuum that pulls the airfoil up. Okay, when plasma actuator is installed on both wings and it is switched on, the electrode will generate an ionized field along the wing area. That will make the airflow to accelerate very close to the actuator surface. When this happens, the local airflow is being modified and the turbulence can be avoided. Okay, now I want to talk about my flowchart. Okay, so the title was selected carefully by research about the project and information. And the information has to be obtained for the research to be successful. After adequate knowledge has been obtained through literature review, this research can now be implemented. For designing and construct the specimen, so the real and approval NACA 4415, let me show you the picture. As you can see, that that model, NACA 4415, which is, sorry, all right, which is the name of the airfoil shape, had been chosen as the prototype to prove and test the project. So for preparation to the type of prototype with magnetic flux is to arrange with copper wire on top of the airfoil. Okay, let me show you the picture. Okay, so as you can see, the picture is an airfoil shape with magnetic flux had been done by Zaim, who is the previous student that worked on this project. So let me turn back to the flowchart. Okay, so now my job is to add more copper wire on top of the airfoil so it can create more magnetic flux. Okay, so the hardware. I want to use a high power supply that can produce high voltage to create more magnetic field and strength of of the magnetic field. The reason I want to do is to improvise the airfoil that had been done by the previous student so that I can improve the flux. Okay, test the prototype and compare the data. So as you can see, here is the picture. It is not my project actually. It is the previous student, but I will test the prototype at the same place as he did, which is at the wind tunnel, and which is at the wind tunnel in UniKL Niat. And I will be using a voltage regulator as well. So for data, I will study the lift and the weight ratio of the magnetic field in increasing more lift. And I will be also study the limitation of the S-peak and the voltage of its utilization. So basically, I will compare among the tests. I will compare among the results that obtained from the experiment that was carried out in the wind tunnel lab on the model airfoil with magnetic field that produced by straight wire carrying current that attached to it. So hopefully that my research will improve the flux from the previous student. Okay, next. Okay, so here's a few reference. Here's a website and thesis that helped me during my FYP time and my presentation. Okay, so here's the Gantt chart that shows me what I do every week from week 1 to week 18. Let's continue Gantt chart from week 18. Okay, I think that's all for me. If you have any question, feel free to ask me. And yeah, thank you for watching. Assalamualaikum.